Hello, my student. In this lecture, we're going to talk about inequalities, how to solve them, how to graph them. Let's go. Most of my students, if not all my students, have trouble with inequality. Let's think about what is inequality. Let's say x is greater than 5. What does this statement mean? It means that any number greater than 5 will make this inequality true. So that number can be 6, 5.5, 5.1, 5.000001, any number greater than 5. This is an easy inequality. Now let's try to do something a little bit harder. In this example, I have 3 minus 2x greater or equal to 8x minus 1. What am I going to do first? First, I'm going to pretend that this is an equal sign and I'm going to solve for x. Let's do that. How am I going to do this? I like to keep all my variables on the left side and all the constants on the right side. My black markers decided that they want to die on me today, so I'm gonna try to use the brown one. I hope it works. Anyway, 8x is positive. When I put it on the other side, it becomes negative. 3 is positive. When I put it on the other side, it becomes negative. So here I have negative 2x minus 8x. That will be negative 10x. And on the right side, I have negative 1 minus 3, which will be negative 4. Okay, here I have negative and here I have negative. When I am dividing or multiplying by a negative, the sign less or equal to or greater than equal to is gonna switch. It's gonna go the other way. Do you see what I've done here? It used to be greater or equal to, now it became less or equal to. And when we solve for our x is gonna be any number equal or less than 4/10. Let's simplify that fraction. So x is gonna be less or equal to fraction 2/5. What are we gonna do now? So there are several ways that you can represent. Usually how you're going to make a note of your answer. So since we have here less or equal to, so I'm gonna put a little note. You're going to use brackets and you're going to make a solid line. I'll explain it later once we start actually making graphs. If I have just less or greater than, I'm gonna have parentheses. And it's gonna be, how do you say it, like pointy or just not solid? Okay, now let's use brackets to write down the solution for this inequality. So any number less than 2/5. So that can actually go all the way to the negative infinity. Whenever you have positive or negative infinity, you need to use parentheses. It's always going to be in parentheses. Negative infinity, because it can satisfy any number less than 2/5. But since here we have less or equal to, we need to use brackets. Okay, now let's graph it. X will be equal to 2/5. So where do I have x? Just put it somewhere here. 5. And any number that will be to the left, that will go to the negative infinity. Here is going to be a solid line. And any number that will be here. And let's use the number line as well, because this one has y and x-axis. The number line only has x-axis. So that will look something like where is going to be a fraction 2/5? It should be somewhere in the middle, but actually closer to 0, somewhere here. But look, here's an issue. When you see 2.5, you need to put a dot, like a little point. Point can either be empty or solid. In this case, since we have less or equal to, it needs to be solid. You see, solid. If it was just less than 2/5, then you would leave that point empty. So we know that the solution is going to be any number less than 2/5 and including 2.5 itself. I mean 2/5 itself. And now this is the solution for your inequality. Let's do another similar example. Here I have 6 minus 7x less or equal to 3x minus 7. And again, I like to put all my variables on the left and all my constants on the right. So I'm gonna move 3 and I'm gonna move 6. 3x was positive, I put it on the other side, it becomes negative. And 6 was positive, when I put it on the other side, it becomes negative. Okay, negative 7x minus 3x is gonna be negative 10x. Negative 7 minus 6 is gonna be negative 13. Okay, now let's solve our inequality. Here I have negative, here I have negative. When I divide or multiply by negative, the sign is going to switch. It's going to look the opposite direction. Okay. And x is greater or equal to the fraction 13/10. We can then convert it into a decimal number. Pick what you want. I like to convert it. Any number that is equal to 1.3 or greater than that is going to be the solution to this inequality. Basically, we'll make this statement to be true. So what will be our lower bound? What is the what is the smallest number that will satisfy this inequality? The smallest number is going to be 1.3. Are we going to use parentheses or brackets? We need to use brackets because it includes 1.3, not just the numbers that are around 1.3, but it actually includes 1.3. And what is the largest number that will make this inequality to be true? Any number greater than like 5, 6, 7, 8, infinity. Infinity is not a number. 100 million, 100 millions, etc., and so on and so forth. And pi as well. Okay, so infinity, and I'm going to close parentheses because infinity is not a number. We are not using brackets. Let's do a little graph. Okay, 1.3 is going to be on the positive x-axis, somewhere here. So any number that includes 1.3 and greater, so it's going to go to the right. And my line is going to be solid because it includes 1.3. And now let's do it on the number line. Oh, 1.3 is going to be to the right of 1. So any number that includes 1.3, if it includes, then the point is going to be solid. So it's going to go to the right, any number to the right of 1.3. This is how you solve inequalities. Now let's do something a little bit more challenging. We're going to solve a system of inequalities. In this example, we have system of inequalities. So it means that we're going to have two inequalities and we need to find the solution that will satisfy both of these inequalities. Okay, how I like to approach this. First, I'm going to use the first inequality and find the answer for that one. And then I'm going to solve the second inequality and see where they intersect, where they are the same. So for the first one, I see that any number that is equal or less than negative 3.6 will make this inequality to be true. Okay, now let's do the same for the second one. And when I solve my second inequality, I see that any number that is equal to or less than negative 3 is going to satisfy this inequality, that will make this inequality to be true. Okay, so here I have any number less or equal to negative 3.6, but here I have any number less than negative 3. I want to do number line first because it will make a little bit more sense, and then we will write it in this format. Here I have negative 3. Is negative 3.6 is going to be to the right of negative 3 or to the left of negative 3? It's going to be to the left. Think about your negatives. Where are negatives? Where are positives? Okay, we are going to the left. And now let's show the first one on the graph, and then let's show the second one on the graph. So any number equal to or less than 3.6. So here I'm going to put a solid dot. Any number less. And here any number equal or less than negative 3. So solid dot. And it's also going to be less than, but I'm going to go with like. And now, what is cool about doing number line before you write it in this format is that you can clearly see where they are shaded in the same way. So like where they intersect. While yes, negative 3 and any number less will satisfy the second inequality, but it will not satisfy the first inequality. So we're gonna go with the area that is shaded on the both, for both. For both inequalities. Any number that is equal to or less than negative 3.6, is that going to be your upper bound or lower bound? Is there any number greater than negative 3.6? No, there is no greater number. So we're gonna put a bracket. And any number that is less than. So we're going to the negative infinity and we're gonna put parentheses. And just like that, let's do another system of inequalities. In this example, we have our first inequality, x plus 3 greater or equal to negative 2, and x plus 1.1 greater or equal to 0. How are we going to do this? By steps. You do first, then second, number line, show it in this format. I don't know how it's called. Just, I guess, write it as a solution. That's just... I don't know. Okay, yeah. When I solve the first inequality, I will be left with x greater or equal to negative 5. And in the second one, I will have x greater or equal to negative 1.1. How are we going to interpret these answers? We know that any number greater or equal to negative 5, such as negative 4, negative 3, negative 2, negative 1, 0, 1, million, 100 million, etc., will make this inequality to be true. Same thing here. Any number greater or equal to negative 1.1 will make this inequality to be true. Will negative 1.2 make this true? No, because you are going to go to the left. Negative 1.1 is greater than negative 1.2. Please review your negatives. Otherwise, this is not going to make sense. So negative 1, 0, 1, 2, 3 million, 10 millions, billions, Google, right? Will make this statement to be true. Let's make a number line. Where am I going to put negative 1.1? To the left or to the right? I gave it away because I left more space. You're going to put it to the right because it is greater than negative 5. This is not drawn to scale. I just sketch it so you can understand it. Okay, let's solve this one. Any number greater than or equal to negative 5. That will be a solid dot. And greater, we are going to the right. That's for the first inequality, and for the second inequality, any number greater than negative 1.1. So negative 1.1 is also going to be solid. And which direction are we moving? Left or right? We're moving to the right because any number greater than. Now, where do these two intersect? They start intersecting when we hit negative 1.1 and go all the way to infinity. So negative 1.1 is going to be our lowest number that will satisfy these inequalities. And now this will be our final answer for this system of inequalities. Inequalities are a very large topic, and I don't want to overwhelm you. So far, we only did 2 variations of inequalities that you can see. And I will make a series for inequalities so you can feel comfortable in your algebra class. And like, subscribe, comment. If you have any questions, let me know, and I will see you in the next video. Bye bye.